Our product title is Comments on and Correction to Unified VLSI Architecture for Photo Core Transform used in JPEG XR. Now we are going to see our product abstract. So in the VLSI we are combining the VLSI and the MATLAB for using the compression the JPEG file image. The image compressions is presented the architecture and achieve the unified architecture design which support the three elements of the PCT, and it has the characteristics is low hardware cost, was initializations and regular structure for VLSI implementation. Finally, the implementation and altern the field programmable gate arrays FPGA device validations effectable of the designs. Now we are give the input from the MATLAB, and then we are DCT transform is based the two key operations of the photo core transformations and the photo overlap transformations. It requires a small number of integration process operations for the structures, and the to transfer the DCT implementations the characteristics that can achieve the moreover the design in the VLSI to MATLAB. So our compression the DCT architecture uses the cryptography applications, and the difference two base level of image compression may be the loss and losses. The lossless compression is preferred the purpose of the often medical imaginations. So main objective for the compression of the image and with using the data bit stored in the VLSI silence code. So we are represent the three-stage butterfly statues within interval address the shifters. The model we are using the 4-bit shift address, and then we have selection line to the coefficients matrix, and end over the reduce the complexity implementation focus the minimization of the address and the critical path of the coefficients calculations. So the latency of the additions operations, moreover the lift based architectures can be utilized in the implementation of the model. We note the lift based architecture to reduce the computational previous operations in that day. The operations implement the three architecture here. We are considered these operations or the same category according to the above algorithms unified with the VLSI architectures. Now we are going to see the product flow diagram. This is a image compression flow diagram. So we are getting the original image from any database from collect from here, and then we are convert to the some image one they didn't give the MATLAB anywhere, and then silence also didn't get to read the image value. So we are convert to the text value. The text value how to we are convert to the accuracy binary points. First of all, split the edge detections. Edge detections get value, and then filter the value so each or every bit. So and then we connect the filter the gray RYB converted to gray, and then applying the red points. The points getting the each every additions under the matrix form we get the values, and then apply the DCT. In the DCT we have the discrete continuous transformation. This transformation we have applying the full read the filtering process and the matrix form also, and then we get the some output the encoding process. In this encoding process we have mux and demux process, and then get to store the one matrix value. So and then we are apply the inverse DCT values. So remaining we get the original values, and then the little bit compressions and decoding the random points. So we get the resize. So every we have give the one picture, and then get the 4 images for filtering, and then input processes the noise and that, and DCT will get that, and the inverse of DCT, and the decode of the points resize of the images. So we are last we have get the compress, and we can check the image of the output. Now we are going to discuss about our product running processor. So this is our product using the MATLAB, and we are getting the from input and construct the input value for images. Only read the image from only MATLAB, and then silence only read the value for only text file. So we are the processing and the conversion, the all the process we are getting the input values compressions by image file only for using the MATLAB. So the main MATLAB file is here. Just I have to run this for our coding. I'm going to run in the processor. So this is get the image value and then read the image. So use the input value from any image from here. So I'm going to select any images from like this image. I get the input images and compress like the ROIB to gray. So this process is converted to the, and then automatically is opening the settings process. After running the settings process, we are getting the input any enter any get display output to the compressed image only displayed on the images. So now the settings will be open. The image it is input images and compressed ROIB, and then black, dark grays. So compressed and then we are using the DCT also, discrete continuous transformation. The silence after automatically open, and then we are going to run these silence codings. So I'm running this process. So the process simulated behavioral models completely successfully. So automatically iSIMS models open. We are getting the process. After complete this process, compress the code wise using the silence software. Code is compressed. After only we are getting using the enter the key in the workspace, and we are getting the output of the compression images. The iSIM tool is opened, and then we have seen the output value and the compress the bitwise data the graphically we have seen, and then we have give automatically inbuilt of clock and recent enable all the give values input value given only through by coding. So automatically it will be generated by the output is coding is buffer, so it will be generated and stored the silence. So now we are going to okay, this is the enter any key of the display output and key enter any key. Okay, so now we are get the some input for output for the compressed image. So this is the compressed and the real process. So this values we getting the images and the same time MSC values and PSNR values and compression ratios always it's also displayed in the workspace command window.